Okay, I will go ahead and start. Uh, Hello, everyone. My name is Manish Pratap Singh. I work at Nutanix. I have today with me Mehboob, who is also works at Nutanix. And today we are going to be talking about the internals of how we have built a mission critical multi-cloud database platform. And we'll specifically focus on the database aspect of it and how we ensure that the metadata is stored and how it is managed and how it is made highly available. What is this platform that I'm talking about? It is essentially a product that Nutanix makes called Nutanix Era. Uh, it is by design a single platform to provide you management services for any app. And by any app, I mean any database of your choice, which is running on any cloud, right? So this image essentially captures the essence of the product. So you could have any of your databases uh, like SQL Server, Oracle, Postgres, MariaDB running over the Nutanix platform. The Nutanix platform itself could either be running on one of your Nutanix clusters, uh, or it could be running on one of the public clouds of your choice. So either it could be in your on-premises environment, or it could be in the public cloud. Now, leveraging the power of the Nutanix cloud platform and the APIs that we get, what we have built is essentially a platform that provides you DB-centric services. Those services are provisioning of databases. Those are data protection of your databases, copy data management of your databases, patching of databases, and going forward, monitoring as well as DR. So what you essentially get is a unified platform to manage all your databases across any cloud. Now let's take a look at the internals of this service, and then we'll make our way to the database aspect of it. So the service is sort of interacting with a lot of components, as you can see in this picture, right? So at the center, you have Nutanix Era, which the users and the administrators at the top are essentially making connections to, right? So they are able to talk to this service and request actions like provisioning, patch my database, take a backup of my database, restore my database, and whatnot, right? The service itself takes ownership of databases shown below. For example, Postgres, MariaDB, MySQL, or Oracle, right? And then it essentially manages those databases with respect to the services we expose. It also reaches back to portals on Nutanix infrastructure for reporting, for metrics and telemetry, right? And it is able to talk to all your Nutanix clusters shown on the right, and essentially take ownership of all your databases running on any Nutanix cluster that you have running out there. So as you can see, the service itself is talking to a lot of components, all the way from end users to the databases themselves, to the virtual machines that you are running. And it needs to be highly available and resilient against failures, right? So what are the major components of this service? We have a Tomcat Java application server, which essentially is built to expose a REST API, user interface, and a CLI interface, right? And all of this is leveraging Postgres as the metadata store. So the service itself has a repository, which is essentially a relational database, which is using Postgres for the metadata. Going forward, we'll focus on this aspect more and see how we have built this metadata available and reliable, right? The service leverages a daemon-based task execution, which means the service never reaches out to your database VMs. Rather, a daemon running on your virtual machines reaches out to the service and polls for any tasks that may be available to be executed for the database, like taking a snapshot, like taking a backup, like starting the database, stopping the database, and any of your day 0 to day n operations. How is the metadata store built? Let's take a deeper look into that now, right? So what we needed in terms of our metadata high availability was the behavior which is outlined here in this flowchart, right? So essentially, what we wanted was for high availability to have multiple virtual machines serving the metadata store. And at any point, if a node goes down, if the node is a primary, we want to promote a synchronous replica to be a primary, right? And if the node is a synchronous replica that has gone down, we want to make sure that we replace it with another synchronous replica so that our high availability is maintained as well as the data durability is maintained. So our requirements were to have multiple copies of the metadata store, have a synchronous replica to ensure durability, and as well as have an automated failover slash switchover, right? So these were our requirements that we had, and we went around looking for the possible solutions for Postgres, which would essentially give us all of this in one software, right? And when we went around, talked to people, we were able to find Patroni. And the solution that we built using Patroni to ensure high availability of the metadata store is something as presented in this picture, right? So essentially what we do is under the hood for our metadata store is we provision 5 virtual machines. So each of these boxes that you see is a virtual machine. There are 3 of these virtual machines are running Postgres software, right? They are running Postgres, they are running Patroni, and they are running HCD. The HCD process running on these VMs, it creates a cluster among itself and basically is used as the configuration store for Patroni. So Patroni supports various distributed configuration stores. Any key value store out there can be used for Patroni, and Patroni has support for a lot of them. And we ended up choosing HCD because it's fairly lightweight, easy to use, and easy to set up. So each of these nodes has Patroni running in it, which is essentially maintaining the high availability of this entire cluster. So if the primary goes down, it will pick a sync replica and promote it to the primary. If the sync replica goes down, it will pick an async replica healthy enough and then make it the sync replica. And we also have HA proxy VMs. And then there's a virtual IP which floats between the HA proxy VMs. So the ERA service, the Tomcat service that I talked about earlier, it essentially is configured to use this virtual IP as the endpoint for the metadata store. So all the reads and the writes come to this virtual IP, and they are redirected through the proxy, and all the writes go to the current Postgres master. And some of the reads, and for some of our workloads and some of our purposes, we also set up a read port. So we are able to essentially redirect all the read traffic to the replicas first, if available, and if not available, to the primary, right? This essentially gave us and met all the requirements that I presented in the last slide and made our metadata store highly available as well as durable, right? Now, why did we pick Patroni and what worked for us when it comes to Patroni? Obviously, open source, right? We all love open source. So Patroni is open source. The architecture itself is very well documented, very well known. The documentation is pretty verbose. And then because everything is so open, you can essentially monitor the development that happens in Patroni. You can monitor the issues they are there, how they are getting fixed, the best practices that are out there for us to understand and leverage all of those, right? So the operational transparency that's there, the open source and the well-known architecture was one of the most attractive things that took us to use Patroni as the HA manager for Postgres, right? And then we realized when we talked to people out there that it was actually very widely used as a high availability solution in on-premises as well as for people managing Postgres in the cloud. So that really enforced our confidence in the solution. Me personally, I like as an engineer the convenience that Patroni gives you, right? So Patroni has a distributed configuration store-based parameter control. So all your Postgres parameters that you want to make sure that are uniform across all your primary and replicas, you can just put them in a distributed configuration store using a very convenient set of APIs or a CLI, and then make sure that they are uniformly set across your primary and the replicas. So in case of failovers, you don't have any surprises, right? It's a very convenient set of APIs and CLIs, and I personally love that. Patroni also has all of its configuration in a YAML format, which lends itself very well to programmatically changing it on the fly, right? So as our product evolves, and if we need to add more features to our Patroni deployment, we are very easily able to read those YAML files, perform manipulations, write them back, and then essentially reload the configurations to make sure that Patroni is up to date and doing what we want it to do. Uh, yeah, so what we were able to achieve using Patroni. So the reason we like this was using this as the metadata store. We were able to build a Nutanix era to be a very reliable and resilient, right? This is the dashboard of Nutanix era, and this is the a very critical service that any customer of ours hosts in the infrastructure, right? So this is the dashboard, and this dashboard is powered by the metadata store running in the backend. How have people been leveraging Nutanix era? Till now, I have been talking about how we leverage Patroni to essentially make the Nutanix era metadata store highly available. And because we have this solution, we actually let our customers use this solution as well. So one of the services that I talked about earlier was provisioning. So Nutanix Era actually lets you provision the very same solution that we use ourselves for our customers. So our customers can bring in their choice of Postgres version, their choice of Patroni version, create software profiles, and provision as many of these deployments as they want, and at the same time have it snapshotted based on an SLA. And you can take the wall backups, and you can restore these highly available databases in house. And all of this beauty and all of this goodness is built in Nutanix Era. So all the way from provisioning a highly available Postgres or a single instance to patching, to taking snapshots, to taking wall backups, to restoring them in house, all of this is exposed to Nutanix Era. And our customers have essentially been using Nutanix Era to build their own database as a service, right? So you install our service in your infrastructure, either on the cloud or on premises, use our dashboard that I just presented, or our APIs and CLIs to provision as many databases you want, to protect them, to patch them, and any sort of day-to-day end services. This is one of the specific examples of our partners using Era. So Wipro has plans to essentially expose and build a database as a service platform, which leverages Era in the backend, right? So Era will be the backend which serves this database as a service to Wipro customers, where they will just be able to consume it as a service. Give me a Postgres database, give me a MySQL database, right? Give me an Oracle database, or give me a SQL Server database. And they don't really have to worry about making sure that this database is highly available, it's protected, it can be restored when needed. And all of this comes out of the box with Nutanix Era. We like eating our own dog food. So all our pretty much services that we have in Nutanix in-house, for example, Gerrit, which essentially hosts our code base, Confluence, which is all the documentation inside Nutanix, and GitLab, which is another code hosting service that we have, they all have the ability to use Postgres. And with our product, with our solution for Patroni and Postgres high availability, all of this are leveraging Nutanix Era provision, highly available Postgres, and making sure that all their metadata is resilient, well protected, and all their day-to-day and operations can be performed using Era. One of the interesting learnings that we have had out in the field, when we went ahead and presented the solution, the platform as well as the database aspect of it to our customers, we realized that Postgres has become over time mature enough, and with the beauty that Nutanix Era provides, they have really started to consider it as a very, very good candidate for hosting some of the banking infrastructure. So we have talked to some mid-level and regional banks who are saying, hey, with the operational efficiency that Nutanix Era provides, and the amazing kernel that Postgres has, and the high availability aspects of it that we just talked, they might as well host some of their workloads, right? Because they like the high availability aspect of it. They understand Postgres. They believe in the Postgres kernel and the roadmap, and they like what Nutanix Era has built on top of it and exposed to them, so that they don't have to worry about the day zero to do n aspects of it, and just manage it as a database as a service. What is coming in next for us with respect to Patroni and Era? We are always adopting the latest version of Patroni. So as and when new and versions of Postgres come out, because Patroni is so convenient for us, we plan to keep supporting all those Postgres versions with the latest version of Patroni. Patroni 2.x has a support for multiple sync replicas. So few of our customers have asked us for that. We are very soon going to be supporting that, and you can use Era to provision Postgres HA using Patroni 2.0 so that it has multiple sync replicas, right? We are looking forward to having more and more people deploy our solution that we provision through Era, in either in the public cloud or in the private cloud, and in the future, maybe container-based databases. That's about it. Just a recap of the people involved here. So myself, I'm Manish Pratap Singh. I'm a staff engineer at Nutanix Era. My co-host is Mehboob Alam, who also works at Nutanix. He's our Postgres evangelist. He helps us get in touch with the community and understand the space and design a roadmap. A special shout out to Alvaro at Ongress. In our initial days of understanding this space of open source Postgres, he was really a good guidance in terms of understanding the options out there. What are the high availability options? What are the softwares we have? Which is the best one for our purposes? And we eventually landed at Patroni with his guidance, right? If you really want to understand what Nutanix Era is, if you really want to dive deeper into the dashboard that I showed in one of the slides, definitely visit Nutanix Era Test Drive. It is one of the best products out there from Nutanix, which helps you build your own database as a service. You'll be able to log into this website that I'm presenting and quickly get your hands dirty with Nutanix Era and just start provisioning single instance or highly available Postgres and play around with it. So I really request every single one of you who is in the databases space, who likes and wants to understand Nutanix and Nutanix Era, to do this. Here are some references, some blogs that we have out there, essentially talking more about the Postgres deployment, the high availability that we expose, and also some YouTube videos essentially talking about how to provision a PG HA database using Nutanix Era, right? Definitely go and check these out. You'll be able to understand a lot more of what we are talking here. That's all from me. Thanks a lot, everyone. If you guys have any questions, we'll take those up, and we'll also be answering questions in the chat. So please feel free to answer. Put your questions in the chat. Thank you.